Hi everyone, welcome to video lecture series on digital image processing. We'll see what is the main objective of digital image processing. Actually, why we are going for digital image processing, what we will learn in this particular subject, digital image processing. The main object of digital image processing is to improve the pictorial information for human interpretation and to process the image data for storage, transmission, and representation for autonomous vision perception. Now, by using this picture, you can understand the main objective of digital image processing. The main objective is, I'm telling, to improve the pictorial information for human interpretation. If you see these two pictures, the picture which is on the left side, if we observe, it is more noisy image and we are unable to identify who is that person standing there. But if you see on the right side image, clearly you can say that who are the persons there and we can identify them clearly. So this is done by our digital image processing only. We have used our image processing techniques and we have made this picture noiseless and so that the picture will be like this which is in the right side if we use our image processing techniques. So that is the main objective of digital image processing, that is for human interpretation we can use our image processing techniques and we can increase the clarity of the picture and as well as we can extract more information by using the picture itself. Next, we will see what is meant by digital image processing. Why we are going for digital image processing. Digital image processing is defined as processing of an image by using digital computer. We will process our actual image by using our digital computer, giving as input to our digital computer, and we will be getting our output, that is digital data only. We all know our digital computer will accept only digital data, so we have to digitize our input data, that is nothing but by using simple sampling and quantization techniques we can digitize our actual input data and we can convert it into digital signal and we can process that particular digital image by using a computer, so that we will be getting our expected digital output by processing that actual digital image. What is meant by image? Image is defined as representation of 3D object by using two-dimensional function. Actually, if you observe, our image is a three-dimensional object. That image will be represented by using a two-dimensional function f of x comma y. So simply we can say image is 2D projection of 3D object also. Now we will see the technical definition of digital image. An image is defined as two-dimensional function f of x comma y, where x and y are spatial coordinates and the amplitude of f at any pair of coordinates x comma y gives us the intensity or gray level of the image at that particular point. Means we are saying image as a digital image. So digital image will consist of all finite elements, that is amplitude values and as well as coordinate values should be finite. Then only we can say that image as a digital image. So a digital image will be composed of all finite elements, and for all those finite elements there will be a particular location and as well as a value. So these elements are called as picture elements and image elements, pairs, pixels. There are so many names. Usually we will be using to refer picture elements as pixels. By using this particular diagram, we can understand that a digital image is composed of all finite elements, that is coordinate values and as well as pixel values. So here we are representing a digital image by using a 3 by 3 matrix. If you observe here, the coordinate values x and as well as y For coordinate values 0, 0, it is a particular location. The particular location is 0, 0. And what is the particular value at that location is nothing but 4. So therefore, for all the elements of our digital image, there is a particular location and defined value. So the location for location 0, 0, the pixel value is 4. And for location 1, 1, the pixel value is 18. For location 1, 2, the pixel value is 56. Like that. 0, 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2. Like that. For all these coordinate values, there will be a pixel value. And this pixel value will give us the intensity of an image or gray level of an image. Next, coming to types of images. We have three types of images like binary image, grayscale image, and as well as color image. If you see the first image, binary image, it will consist of only two levels, that is pure black and as well as pure white. It will consist of only two levels. 0 will represent for pure black and 1 will represent for pure white. So it will consist of only two levels, so that we are calling it as binary image, or we can call it as black and white image also. Next, coming to grayscale image. Grayscale image, if it is 8-bit image, then 2 power 8, it will consist of total 256 gray levels, or 0 to 255 gray levels. So in that 0 to 255 gray levels, that gray levels will be like black and variations of black, and white, variations of white. Means here there will be so many variations between black and white, variations of black and as well as variations of, means here the black color is slightly blending to change to the another color, that is white. So there will be variations, that is nothing but we will call it as grayscale image. Next, coming to color image. Color image will consist of three bands like RGB, CMY, CMYK, HSI, like that. All these are nothing but color images which will consist of three bands for each color. That is examples RGB, HSI and CMY, and then CMYK. Those are the color images. Next, we will see the applications of digital image processing. There are so many applications of our digital image processing. Means we are telling that we will take an image as input for our digital computer, and we will process that particular image so that the resultant image or the resultant output will be more suitable for our certain application. Depending upon our application, we will give an input image and we will process the data by using our image processing techniques, so that that resultant will be more suitable. So there are so many applications of our digital image, that in that we will see a few applications here. The few applications are, first application is medicine. If you go, if you observe, there is a huge application of image processing in medicine. Why? Because in medicines, there will be X-ray images, there will be dermoscopy images, like digital images will be there. Then we will process that digital image by using image processing techniques like image enhancement, pattern recognition, image restoration. What these techniques will do means they will process the data and they will give the output like the parameters of the image. The parameters of the image means attributes of the image. For example, X-ray image is there. Then if you will see the report, there will be that sugar level, what is the sugar level of that particular patient, or what is the height of the patient, or what is the weight of the patient, what is the blood level of the patient, like that. All those are attributes of that particular image, means that is processed by our image processing only. So in medicine, there is a huge application of our image processing. In telemedicine also there is a huge application, like we can send our information, we have to store that data and we will send that information from one source to the other destination. The compression techniques, with efficient compression techniques, we have to transfer that data without any interruption, without any noise. For that also image processing techniques will be useful in telemedicine. And if there is a dermoscopic image like a cancer image, we will take that cancer image and we will do our image processing techniques like segmentation, enhancement, and as well as recognition, texture analysis. By using that, we can identify that where that particular cancer stage is, whether it is in first stage or second stage. Like that, we can doctors can identify easily by that particular output image, where that output image is more suitable for our application, the resultant output. So there is a huge application in medicine. Next, coming to forensics. Forensics means security. The security can be enhanced by using a personal identification. A personal identification, what will be taking, they will be giving biometrics and as well as face recognition, iris, like that. All those things should be pre-processed for efficient identification. So for that, pre-processing techniques are used in our by using our image pre-processing techniques. So enhanced pre-processing techniques is used by using this for this particular forensics application, so that the resultant will be more suitable, the resultant image. So the enhanced security will be there in this particular forensics for personal identification. Next, coming to remote sensing. In remote sensing also, there will be some satellite images, radar images, and as well as so many images will be there. So those images we will be processing those images, like remove the noise, like pre-processing, and as well as we will acquire our image acquisition techniques will be using, pre-processing techniques will be using, pattern recognition techniques will be using, enhancement techniques we can use in this particular remote sensing applications also. And then communications. Nowadays, multimedia has a huge application. There is a huge development of multimedia. So in multimedia, like video conferencing, the data should be transmitted very fast. Like in video conferencing, nowadays we are using Zoom meetings. In all those Zoom meetings, the data should be sent in very fast manner. So there also our image processing techniques like compression techniques will be useful for transmission of data from one place to the other place. So the digital image processing will play very important role in communications also. So there are so many applications are there for our digital image processing techniques. So we'll be performing some fundamental steps for our image, then we'll be getting our output, so that output will be useful for our application. So it is purely application oriented. So we have to see first what type of fundamental steps we are using for our processing techniques. So those are for our image processing by using a computer. I already told you, digital image processing is processing of a digital image by using a digital computer. So there are so many fundamental steps like image acquisition, segmentation, enhancement, restoration, and as well as morphological processing, compression techniques, recognition, and registration. Like that, so many fundamental steps are there. In the next lecture, we are going to see the fundamental steps of our digital image processing. Thank you all.